Hello, my name is Mark, N6MTS, also known as Smitty Halibut. I run Halibut Electronics here. I'm also a host of the Ham Radio Workbench podcast, if you've ever heard of me there. Anyway, let's talk about what products I've got here today. On the bench here, I am presenting the Open Headset Interconnect Standard. What the heck does that mean? Well, the Open Headset Interconnect Standard is an attempt to standardize the interface between the radio and the user. Notionally, that's a headset, but it doesn't have to be a literal headset, just something with a microphone and some speakers and a push-to-talk. So right now, if you buy a headset, like this wonderful Radio Sport headset, when you buy it, you buy a cable that goes from the Radio Sport to a specific radio. And if you want to take that headset to a different radio, you have to buy a different cable. And then if you want to buy a Heil headset, then you have to get an adapter that goes from the Heil cable to that radio. And if you want to hook that up to another radio, you have to buy another adapter. There's a full mesh of adapters between all the different headset options and all the different radio options. If you're in a home shack, that's not too big of a deal. But in a multi-user environment like a club shack or an EOC or a field day event or a contest station, your adapter game has to be strong. You have a whole lot of adapters. It's a full mesh between all the different types of headsets and all the different types of radios that you have in that environment. And that just gets unwieldy very quickly. And that's the situation we're in right now. So what I have done is I have proposed a standard called OHIS, Open Headset Interconnect Standard, that defines the electrical signals and the physical connection of that interface between the radio and the user. In a perfect world, all the headset manufacturers and all the radio manufacturers would adopt this standard natively, and I would just be able to buy a headset and plug it straight into my radio. That's what we would love to have. That's going to be a long uphill battle to get everyone on board with that. We know that. So in the meantime, we need to use adapters to connect the two. Well, how is that any different than the adapters I just described as being a pain in the butt? Well, what I'm going to do is I'm going to take that one adapter that goes from that one headset to that one radio, and I'm going to take that adapter and split it into two parts and put a standard interface in the middle. So now I've got one adapter that goes with one headset. This adapter is unique to this headset, not this headset and some radio, just the headset. And it stays with this headset. So now this headset through the adapter has a standard interface on it. Similarly, if I go over to my radio, this radio I have an adapter. This box here, I have an adapter that goes from this radio to the standard, whatever this radio is. All of that conversion is handled by this adapter, and now my radio has a standard interface. And when I've done that with all the headsets and all the radios, now I can take any headset and plug it into any radio. That is the goal of OHIS. And in the meantime, we're going to be doing adapters to make that happen. But now this radio only needs one adapter to go from that radio to the OHIS standard, no matter how many different types of headsets are going to plug into it. That is OHIS. That is my goal, to get that standard adopted. Again, it's going to be a while before the radio manufacturers get on board. That's just the reality. They've got a long development cycle, and no one radio manufacturer wants to be the only one to adopt the standard. So we need to get everyone in a room together and have them talking and all agree, okay, yep, this is a standard, we're going to do this. The next products that we release will include this standard. I'm not asking them to retrofit anything. So hopefully we're going to make that happen. In the meantime, we got the adapters. However, once you have a standard interface between the user and the radio, it makes it a lot simpler to design a device that goes between the user and the radio. For example, I have a device here that I call the contesting console. The contesting console, this is not part of the standard, it is a product that I make that uses the standard. The contesting console connects two users to one radio, right? So let's say you've got an operator and a logger in a field day event. right? The operator is the one who's calling CQ and responding to the people who are calling, and the logger is listening to the radio as well, and they're both listening for the call signs, and the logger is the one who's typing it in. And if one person, doesn't quite hear the call sign correctly, a lot of times you say, "What was that again?" And without an intercom, you're having to pull the headphones off so you can talk to each other or whatever. The contesting console lets two people listen to the same radio and provides an intercom between those two users, so they can hear each other through their own microphones. And then whichever user presses their PTT, that user's microphone audio gets sent to the radio, but not the other one. And so in that way, it's a device that lets two users use one radio in a contesting environment. That's the device I really want to build, the unique device that adds functionality to a thing. The adapters are just kind of a means to get there, because otherwise I would have to build all that complexity of what type of headset is it and what type of radio is it. I would have to build that into my contesting console, and so I would rather abstract that complexity out into adapters. And if we're going to make those adapters, we need to make them standard so that everyone in the industry is using them, and we're not all having to buy individual adapters for all the different products we're making. So this is an example of a user adapter. The user adapter is what connects the headset, adapts the headset into the standard interface, the OHIS standard. So this is what I call the HHI User Pro. HHI stands for Halibut Headset Interconnect. Those are the Halibut Electronics products that implement the OHIS standard. So this is a finalized product. It's completely built and pre-configured for the types of headsets that you buy, or that you tell me you want. But you can still open it up and reconfigure it for a different type of headset if you ever change what headset you're using. It has a built-in PTT, so this can be your hand switch. As you're trying to operate the radio, this is your hand switch. It also has a mic level adjust there because people speak at different levels and microphones have different sensitivity, but the standard level for OHIS is a specific level. And so on the RJ45 connector, there are a couple of LEDs here that act as a VU meter. And so the goal is to put the headset on and start talking into the headset such that the green LED, the green LED blinks most of the time, and the yellow LED only blinks occasionally. And you adjust the mic level until you get to that situation. And then that is correct mic level. And then on the other side, you have three different connectors. They're all 3.5 millimeter connectors, TRRS, so 4-pin connectors. And you can put any signal on any pin of the headphone or microphone connector. So no matter what the pinout is of these connectors, whether you have a radio sport or whether you have an ICOM or whether you have a PC gaming headset, the 4-pin CTIA headset like you would get for a mobile phone back when we actually had headset ports on our mobile phones. No matter which one of those connectors you have, you can put the right signal on the right pins on these connectors in here to make them work with those different connections. And then there's also a microphone preamp in here. So the OHIS standard is an electret microphone signal, which has a higher level than dynamic microphones. So there is a preamp in here that if you plug in a dynamic microphone in here and you put the preamp in circuit, then it will take that dynamic microphone and bring the level up to be about the same as an electret microphone to make it standards compliant. So this device right here can take just about any headset on the market that has 3.5 millimeter plugs and turn it into the OHIS standard. That is what the goal of this one is. These are full final products. Some people don't necessarily want to spend the money on a full final product, and they would rather have something a little bit less expensive and maybe a kit that they would like to build. And so this is my open source OHIS user adapter. This is an actual open source design. You can go on the web and download these files without paying me any money and go off and have these boards fabricated for yourself and buy these parts for yourself and build this yourself. It's a great club project, by the way. Or if you would rather, you can just go to my webpage and I'll sell you a kit with all the parts in it for less expensive than this, because you have to build it yourself. But this is basically the same functionality as this. It does not have the VU meter in it, so you're on your own for setting the mic level. You can still set the mic level with the potentiometer here, but it doesn't have the VU meter built into it. But it is a much less expensive way of adapting whatever your headset is to the OHIS standard. And the other advantage to it being open source is that you can download the files and look at the schematic and learn how OHIS works by looking at an example schematic that adapts OHIS to a headset. So in that way, I really like this design. This is the Halibut Headset Interconnect HHI Radio Pro. So this is a finalized product that does the radio adapter, right? So you can see all the different connectors on the back here that you can use to connect to different ports on your radio. If your radio uses an RJ45 for the microphone, you have that here. If it uses this round 8-pin Fostech connector, it's also known as a GX16. You can use that to connect to your radio. Or a 3.5 millimeter socket here for the microphone. There's an RCA here for PTT, and then a 3.5 millimeter for headphone or speaker over here. So all of these, whatever you need to use, can connect to your radio to get all of those signals, whatever the radio signals are. Then inside is a board called the configuration board. This board is a matrix of solder jumpers. So every column on the board is a signal. So like headphone left, headphone right, headphone ground, those are each separate columns. And then every row on this matrix is a pin on one of these connectors. So in that way, by dropping a solder blob onto the correct jumper, or the way I do it when I manufacture is I have them put down a 0 ohm resistor, you can connect any pin, any row, to any signal, any column. And so you have a complete flexibility over what the pinout is on each of these connectors, right? So that's how we handle the fact that Yaesu and Kenwood and ICOM all have different pinouts for their 8-pin round or their RJ45 microphone connectors. And then there are also a couple of trim pots, a few trim pots down at the bottom of the board to set levels for the difference between a dynamic and an electric level, or whether you have a speaker level coming out from the radio or a headphone level, that kind of thing. So you can set the different levels using the trim pots, and then you can set the pinouts using the solder jumpers. Then one of the other features that my product has, you'll notice that these are all the connectors that go to the radio, because that's the back of the device. It's got the Anderson power pole on it. If you flip it around, you have all the same connectors on the front, but instead of the Anderson power pole, I've got an RJ45 here. This is the OHIS port. But what are all of these on the front for? These are the same connectors as the ones on the back. Well, when you have your 8-pin round connected to the 8-pin round on your radio that your microphone normally connects into, you can no longer plug your microphone directly into your radio, right? Because that cable is in its place. So instead, what I did is I created pass-through ports on the front. So if you have the back connected to your radio, then you can plug your radio's normal microphone into the front of this device, and you can still use it like normal. All of the signals get passed through to those same connectors on the front panel whenever OHIS is not using them. The receive audio gets split and goes to both the original speaker and to OHIS. And then when you press the PTT on OHIS, that microphone will get sent back to the radio. There's a little relay that switches over. But normally, the standard mic is connected through, including on the PTT line. So in that way, you don't lose any of the functionality by connecting these cables into your radio, because you still can plug all of those things that used to be plugged into these ports here. So that's the Radio Pro. Just like on the user adapter, I made these open source versions that are kits that you can either download the files and make them yourselves or just buy a kit from me. I am working on doing the same for the radio adapters. I haven't gotten there yet. I know how I want that to work. It's a more complex problem, and so I'm trying to nail down exactly how I want to productize those, whether it's one device that the user reconfigures or whether it's multiple different devices with no configuration. I'm still trying to figure that out, but I will be making an open source version of a radio adapter that probably won't have the pass-through, It'll just do the converting from whatever your radio is to the OHIS port, but it'll be much less expensive than this. Much smaller, much simpler. It is something that you can build yourself. It is something that, being an open source design, you can build it into your own product, that kind of stuff, right? So that's the radio adapter. So those are the Halibut Electronics products. Those are not all of our products. We have some more, like our common mode current choke test rig and our Halakey, which lets you work CW remote with your Flex radio when you're not near your radio itself. You can plug in your CW key into your laptop that you're using to connect to your Flex radio remotely. We have lots of different products. So please come visit us at our website, electronics.halibut.com. Or you can email me. I am mark@halibut.com. You can find me on YouTube at Smitty Halibut for my personal YouTube, and then the company YouTube is at Halibut Electronics. Sense of pattern forming here. Yeah, that's it. Thank you so much, and we'll catch you later. Be good humans.